Hello everybody, welcome to Anantha Lakshmi Academy. Today we are going to discuss a concept which is needed for us to solve the third exercise of tangents and secants to a circle. The concept is segment of a circle formed by a secant. Let me put it on the board. This is a segment of a circle formed by a secant. So even before this, the very first part, if you have gone through the introduction part wherein I have mentioned all the concepts like what is a circle, what is a secant, what is a tangent, what is an arc, what is a sector and all. So if you are directly coming to this, please, I would suggest that please go through that first so that you will feel this a bit familiar. Okay. So what is this segment of a circle formed by a secant? I told you when I draw a secant, what is a secant? If a circle touches, if a line touches the circle, that becomes a tangent. But if a line intersects the circle at two different points, then that is called secant, is what we said. And the secant divides the circle into two segments. One is the above one, major segment. What is major segment? Something which is big. Okay. And the bottom one is nothing but minor segment. Okay. This is what is minor segment. So what are these segments? How are they formed? They are formed by the secant. What is the secant which is intersecting the circle at 2 points? AB is chord. This line L is a secant. Okay. AB is nothing but a line which touches the circle at two different points. That is a chord. But a line which intersects the circle at two different points is a secant. Now, secant is dividing the circle into two segments. One is major segment and the other is minor segment. It is not necessarily the same thing if you draw something somewhere in the middle, or it may divide it into two equal semicircles as well. Okay. For now, for the example sake, I have drawn a secant here which is dividing it into unequal halves. Which one? The one with more area, we consider it as a major segment, and the one with the minor area we consider it as a minor segment. Now, let us locate the center of the circle. From here, I am joining OA and OB. Okay, OA and OB. What is OA and OB? Distance from center to any point on the circle is nothing but radius, isn't it? Now, these radius are making an angle at O. Okay, we do not know what is that angle. Now, if you look at this, OAB is forming a triangle. Now, segment of a circle formed by secant. In this concept, we are going to learn the area of the segment. The area of the segment. If you look at this, the segment is nothing but AB. This AB part, isn't it? If I consider this as P, APB is the segment, isn't it? So we need to know area of the segment. We are going to learn area of the segment, which is equal to, I don't know how to figure out the area of this particular shape. So what I am going to do is, I know what is a sector. What is a sector? The arc which is in between two radii is known as a sector. This is also has been discussed in the introduction part. Alright. So this from O, A, B, this becomes a sector. Alright. So area of the segment is equal to, I am going to write it as area of sector OAB minus, we are interested only in this shaded region, right? So minus, I am going to subtract this area of triangle OAB. So area of sector OAB minus area of triangle OAB. Alright. So I told you, right, this particular angle is made between the two radii, which let us consider this as x. Alright, so in order to get to know this shaded part area, what we have done, we figured out the area of the sector first, minus we are going to subtract the area of the triangle. What is going to remain? This particular part, APB. Alright, so that is how we are going to deal with the area of a segment. That is what we are going to solve in the coming exercise. So what is the area of a sector formula? X by 360 into pi r square minus area of a triangle OAB. Any area of triangle is given by half BH. This is how we are going to figure out the areas. Alright, this is the concept and the introduction that is needed for us to understand exercise 9.3 problems. And now that we are done with the concept, what is the next part for us? It is time for us to go through the examples. So please go through the examples even before we start the exercise problems. So I hope you have gone through the examples and I am ready with the first problem already listed on the board. So let's get through it first. Okay. It is given that in a circle of radius 10 centimeter, radius of the circle is already given for us. A chord subtends a right angle at the center. A chord subtends a right angle at the center. Find the area of corresponding minor segment and major segment. There they asked us to use the value of pi as 3.14. In mostly all the problems they are giving us either to use fractional value or decimal value. Okay, fractional value is 22.7 and when it comes to decimal value it is 3.14. So let's get started with the solution first. Given that there is a circle of 10 centimeter radius, okay, and here a chord, let us assume this as the chord AB, it is subtending a right angle at the center. So this is nothing but a right angle. Okay, now find the area of minor segment. This chord is dividing the circle into major segment and minor segment. What is this? Major segment. And this is minor segment. Okay, how do we figure out the minor segment area? We just now discussed, right, the concept wherein we figure out the area of the sector OAB first minus area of the triangle, that is going to give us the minor segment area, isn't it? So let us write given. What is given for us? Given radius is equal to 10 centimeters. Radius is R. And what is the angle that is given? This is a right angle. So x is equal to 90 degrees. So area of the sector is what we are going to figure out first. Area of sector OAB is equal to, what is the formula? X by 360 into pi r square. X is 90 by 360 into, what is the value of pi? We are supposed to use 3.14 into 10 into 10 r square, right? So 94 is a 360. This is, so 314 by 4. If you multiply 100 with 3.14, it becomes 314 by 4. So if you do the cancellation part, 4 sevens are 28, 34, this becomes 8s are 32, 0.45s are 20 centimeter square. Radius is given in centimeters itself, so this is going to be centimeter square. Now that we got the area of the sector, we need to also know the area of triangle, right? So this is radius 10 centimeters, this is radius 10 centimeters. In order to know the area of the triangle, what do we need? Base and height. Area of triangle OAB. As this is a right angle triangle, half into, what is the base? This is the base. 10 into height is the opposite side, which is 10. So 2 5s are 10 and this is going to be 50 centimeter square, isn't it? So what is the area of segment now? Area of sector minus triangle. So that is going to be area of segment. Which segment that is? Minor segment. The first bit. This is area of minor segment. is equal to area of sector OAB minus area of triangle OAB, which is nothing but 78.5 minus 50, which is 28.5 centimeters square. That's about the first bit. What is the second bit we are to figure out? The second bit is area of major segment. How did we figure out minor segment? Sector minus triangle. Now, this major segment, this segment is nothing but, how do we figure that out? Try doing it, try guessing it. In the meanwhile, I'll be writing it on the board. Area of major segment. Keep trying, keep trying. Did anybody get that? If not, just look at this. See, this is the whole circle, right? Circle minus, now we know the minor segment area. If I subtract minor segment area from the circle, what do we get? Nothing but the major segment area. That's what I have written. Area of major segment is equal to area of circle minus area of minor segment. So area of the circle is pi r square, right? Minus area of minor segment is 28.5. So this is again 3.14 into 10 minus 28.5. That is 314 minus 28.5. If you do the subtraction, this is 13. 10 minus 5, 5. 13 minus 8, 5. And this is like 10. 10 minus 2 is 8. And this is 2. So this is going to be 285.5 centimeter square. Alright, so that is about the very first problem of exercise 9.3. That is how we need to figure out the major and minor segment areas. Alright, so let's look at the next problem. So here we have the third problem. The second problem is exactly similar to the first problem, so I am not solving that for you. I have jumped into the third one. So here it is given that a car has two wipers which do not overlap. Generally, you must have seen cars, right? While it is raining, there will be wipers which will be rubbing the water against the glass. So that will be like, if you assume this as the car's mirror, they will be in this direction like this. Okay, they will be moving here and there such that it forms semicircle kind of stuff. Okay, so they do not overlap, and each wiper has a blade of length 25 centimeters, it seems. So this is 25 centimeters and this is also 25 centimeters, sweeping through an angle of 115. What is this angle? 115. This is an obtuse angle, more than 90 degrees. So I have drawn it that way. Okay. Each of them is making an angle of 115 degrees. Find the total area cleaned at each sweep of the blades. So there are two wipers of equal radius and making equal angles. So if we are to find the total area cleaned at each sweep of the blades, if you figure out one area, if you double that area cleaned by one wiper, that would be enough. Okay, since the measurement and the angles are equal. Okay, let's look at the solution. Given length of the wiper is equal to 25 centimeters. And next, angle made by the wiper is equal to 115 degrees, right? So, area cleaned at each sweep by two blades is equal to 2 times it is like a sector, no? So this is going to be x by 360 into pi r square. So we are going to handle this as 2 into 115 by 360 into pi as 22 by 7, right? Into 25 into 25. All right. So let's do the calculation here. If we cancel it with the 5 table, 5 2s are 10, 5 3s are 15, 5 6 30, and 60, right? 5 1s are 5 2s are, hold on, 5 7s are 35 and 10, right? 5 2s are, so 2 11s are, 2 3s are, 2 6 are, 2 18s are. So this is going to be anything else? No. Okay, 23 into 11 into 25 into 25 by 18. All right, if we do this calculation part, 18 and into 7, this is okay. If we just do this calculation part, we are going to get the answer as 1254.96 square centimeters. Okay, this multiplication and division you have to do in the exam. There is no other way. Till how much ever we could simplify, we have done, and you have to do this division part. Okay, that is about the third one. Let's look at the next one. So here we have the fourth problem. Let us read it out. So find the area of the shaded region in the figure, where ABCD is a square of side 10 centimeters. Okay, the side of a square is 10 centimeters is what is given, and semicircles are drawn with each side. So this is like, this is a semicircle and this is also a semicircle. Okay, with each side of the square as diameter, use pi is equal to 3.14. Okay, what is given for us? What did they say? ABCD is a square and side is given with the side as diameter, isn't it? Diameter D is equal to 10 centimeters is given. Radius, so what does that implies? Radius R is equal to D by 2, which is 10 by 2. Why am I figuring out radius? Because they said semicircles. We need to figure out the areas, right? So let me note the empty space as 1, 2, 3 and 4. Okay, now there are 4 unshaded parts and 4 shaded parts. In order to get the shaded area, in order to get the area of the shaded region, I am going to subtract the unshaded region's area from the area of a square. If I subtract area of the square, if I subtract the parts 1, 2, 3, 4 from area of square, that is what we are going to get as the area of shaded region, isn't it? So let us try figuring out area of region 1 and 3. Let us figure out first 1 and 3, right? The semicircle AOD and BOC are there. This is the center, no? AOD and BOC. Okay, is equal to, how do we figure out the parts? Area of the square minus 2 times the area of semicircle. There are 2 semicircles, no? So area of a square is nothing but 10 into 10, 100 minus 2 times the area of semicircle, that is nothing but 2 into half into pi r square. Pi is 3.14 into 5 into 5. 5 is a 25. Okay, so this is 100 minus 3.14 into 25. Let's do the multiplication. 25 4s are 100, 25 1s are 25, 35, 25 3s are 75, 7, 8. So 78.5 this is. So 100 minus 78.5. Let us do the subtraction. 10 minus 5, 5. 9 minus 8, 1. 9 minus 7, 2. So this is going to be the 21.5 square centimeters. What did we figure out? The area of 1 and 3 alone. Likewise, since we are dealing with a square, similarly, area of region 2 and 4 will also be equal to 21.5 square centimeters. If you want, you can evaluate this. The same area of square minus that this particular semicircle, COD and AOB. Okay, that also you can do. You will get the same thing. I have tried and I am just writing it like that. Okay, now we know 1, 2, 3, 4. These areas we know. Now, in order to get this shaded part area, we need to subtract these 4 areas from area of square, isn't it? So, let us do that. The area of unshaded region, the total area of unshaded region, total area of unshaded region this is, okay, that is equal to 1 and 3 plus 2 and 4, no, 21.5 plus 21.5. 43.0 square centimeters. Now, in order to get the area of the shaded region, so therefore, area of shaded region is equal to area of square minus area of unshaded region, which will be area of square is 10 into 10. 100 minus unshaded region is 43, right? 43.0. So 10, okay, 43.0 is nothing but 100 minus 43 is 10 minus 3 is 7. 9 minus 4 is 5. 57 square centimeters. Alright. So the area of the shaded region is 57 square centimeters. That is about the 4th problem of exercise 9.3. So I'm going to close this video here as the video is becoming lengthier. We will continue discussing the rest of the problems in the next video session. Till then, if you like the content and able to understand my explanation, please do like, share and subscribe to Anantha Lakshmi Academy. Also, please share it with your friends or 10th class mates or any of your relatives studying in 10th class. Thank you for watching.